we have Burkhard Birken, who is the CTO of Hexagon. Burkhard has been working on digital reality and robotics for over 20 years, and Hexagon is exploring how digital twins and spatial AI will intersect to catalyze the adoption of humanoid robots. And I'm excited to learn a lot more about this, and I hope you are too, so please welcome Burkhard.
Thank you very much for the introduction. Welcome everyone. I'm Burkhard Birken, I'm the Chief Technology Officer of Hexagon, and today we are going to talk about the power of precise digital twins for humanoid robots and why we have the technology required to make the world work better and the ability to know before we act, and we simply call it the age of autonomy. So the vision for humanoid robots is that they will accelerate innovation, that they will automate repetitive tasks, that they will help us overcome labor shortages, and that they will eliminate waste, and this in terms of wasted resources and wasted time. So advancement in AI and simulation and reinforcement learning are unlocking the potential of these robotic systems, but we think we need to go further. So we need to use precision to unlock actually the spatial intelligence, and we need to create, as you see it here, digital twins that allow robots to anticipate and learn even better and faster. And it starts with data and an ecosystem to build the most precise digital twin possible. And building these digital twins at any scale, as you see here, and I go a little bit more in depth throughout this talk. And it's about giving robots and then AI access to accurate, up-to-date industry insights. And when we do this, we will empower humanoid robots to navigate complex environments and accomplish complex tasks. As I said, it all starts with data, but data are just symbols, mostly numbers. We make them more machine readable, it's zeros and so on, and we create vast amount of data. Researched a bit, by 2025 we will have created, copied, recorded, and consumed 181 zettabytes. And I had to look it up. 1 zettabyte represents 1 billion terabytes, where each of us creates an average of 102 megabytes per minute. So our data volumes are growing by 23% every year. But as you see, data is not very useful on its own, and so we get into the topic. What you see already here is a point cloud generated by one of our Hexagon devices. Is a Leica scanner, it's an RTC 360. However, it looks already a lot like information, but we need to dig a little bit deeper. And even the information that you have contained in this point cloud is enough. So we need to transform the information into knowledge and gain a deeper understanding of a problem or a situation. As you see here, the point cloud is already segmented in various parts. And only at this point, we have a basis for insights and the opportunity to get a complete 360-degree view so that we can make the right decisions at the right time. But we would like to go even further, though we connect insights back into the world to create impact, to really make a difference. And that applies to all the industries that we work for, whether it's for manufacturing, whether it's for construction, whether it's for process industry or others. There are many reasons why projects are delayed, cost overrun occur, and problems occur. And let us use these insights to make a long-term impact and overcome these problems while we navigating and reasoning the robots. So we are in the age of autonomy, and an age where innovation accelerates in unprecedented speed, as we see here. And why are digital twins so important to humanoid robots? And what does the ecosystem built around look like? And this is a blueprint on how we go about these things. You have the real world, you have a lot of sensors, and then you create a digital twin. And then you apply AI to the data, you do spatial computing, you use it to train it and get greater robotic performance, and then you basically deploy it back into reality. So this becomes a flywheel, this becomes a feedback loop. And we're doing this since quite a long time. As Hexagon and all the vital industries. Some key figures, what we do, our public safety technology protects over 1 billion people. Construction technology that is around the digital twins is active on over 350,000 construction sites, and it's used in over 90% of the airplanes. And I could go on and on and on in these 28 industries where we are. So we bring a long history of industry experience and innovation to the robotics field. I showed you the blueprint, but to form the ecosystems we need exactly 3 things. To make a digital twin, to generate insights from the digital twin, and to activate the digital twin back into the real world. So how do we make digital twins? And it's a lot about the reality capture sensors that provide the most accurate perception and data generation available today. Today, basically, these sensors that they fuse various capture methods, it's imaging, is LiDAR, is structured light, is radar technology, and is for photogrammetry. And these technologies have been there for decades to accurately map the world and objects across every major industry. How does it look like? Let's begin with industrial metrology, where we measure objects on the manufacturing shop floor, whether it's large volume metrology with laser tracker controlled handheld scanning, or robotic scanning using large gantry machines, as you see here in the video for the flushing gaps. And if we go bigger scale, and if our robots want to go bigger scale, then entire cities and countries are mapped using car-based mobile mapping system. And as you here see, airborne sensors, then sensors that fly with planes. So I showed you at the beginning, the start is a point cloud, and these point clouds are processed into meshes. And the imaging sensors that normally in our scanners are on board then generate the textures and the coloring. So as you see it here in this corridor, the photorealistic 3D meshes are the results. And this does not only work in very small scales like indoors, this also works in any scale. What we have seen indoors also working with the same methodology in a city like New York or Munich, as you see here, so fusing the terrestrial and the airborne 3D reconstructions together, we call it super mesh. And this is an ideal background where basically our robots can autonomously navigate and perceive the environments. But we can do this reality capture not only manually by human interaction, we can also do it with robots. Let's talk about robotics and reality capture. Robots and precision sensors go together very well. So we make robots carry precision sensors to capture reality and make therefore digital twins. They connect the digital twins via platforms and automate repetitive tasks. And there are few aspects that all our autonomous systems have in common. We use computing at the edge. So basically the result is at the machine, at the sensor. We use autonomy through robotic capabilities, and we connect the digital twin to reality. And these robotic reality capture systems are embodiment of AI. So let's talk about robotic ecosystems. That's robotic platforms that navigate and scan spaces without human intervention, and sensors adapt to the environment by continuously capturing reality, and artificial intelligence-based software connects directly to our autonomous sensors and processes that these data sensors create in real time. So combine these technology, create a complete autonomous system, complete autonomous workflow, from data capture to creation of deliverables, insights, and as I showed before, experiences. And such a systems that we probably, for the first time in 2021, put on a Boston Dynamics spot. We call it BAK ARC. BAK is our reality capture line, and ARC stands for Autonomous Reality Capture. It revolutionized in 2021 the way that we captured and navigate in 3D spaces autonomously. And as a module, it can be integrated with many different robotic platforms for very different applications. And then throughout 2021 and 22, we gave the BAKR a set of wings, and we invented a completely new flying systems from ground up. We called it the BAK to Fly. Was the world's first autonomous flying laser scanner, a system that won the Time Innovation Award in 2022. And what makes it autonomous is that it enables users to capture complex buildings, as you see here, and structures completely autonomous from facades to roofs, bringing reality capture to previously inaccessible spaces. And as an autonomous system, the BAK to Fly creates its own scan path and flies around structures and while capturing reality in 3D. And after a successful mission, as you see it here, it returns home safely. So we have created now a digital twin, and now it's time to generate insights with the application of AI. And we're doing it in Hexagon in 6 platforms that are geared towards specific industries to have their own domain knowledge representing in there. And these platforms, they connect people to meaningful data, and they foster also the collaboration in the industries where we are. For example, probably the one that is most relevant for the robotics industry is called HXDR, Hexagon Digital Reality, which makes sense of the data and create insights that later on also robots can use by training in this environment. So basically, you train the robot before you deploy the robot, and when the robot comes into a scene, we already know the scene. And this is an example we did in 2023 jointly together with NVIDIA. We created a digital twin and used it to simulate and optimize the manufacturing process, and then bringing, for example, from the digital twin, from various processes that you run across the digital twin into Omniverse and then back into reality. So all our platforms enable to innovate quickly and provide our customers with valuable new function, and this is the way we guarantee that our global R&D teams can leverage the best domain expertise to provide AI-powered digital twins, which comes in all of shades and colors in terms of visualization. And this is basically before you enter with a robot, with a humanoid robot, this scene. This is already the training ground, so the environment's already known. Now let's talk about AI. Where is the state of technology in this geospatial AI that we are using here, and what is available today, and how it works in this industrial application, which is probably a little bit different than the large language models or the generative AI. In which areas is this possible and already released into products and platforms? And we have done it quite early on. So for us as a company, having image sensors, having LiDARs, it was already a topic in products in 2012. And when deep learning arrived around about 2014, we developed already classifiers of identified objects in terabytes of 3D point clouds. And our initial experiments with generative AI started around 2018, and when 2022 the breakthrough came, of course we were quite nicely positioned. And we have already incorporated our AI capabilities, as you see it here, in these platforms that I was showing before, into multiple products that are actually active on the market today. And we're working now with strong acceleration with our partners NVIDIA, Microsoft, and AWS. What can these platforms do in terms of AI classification and segmentation of point clouds? Extremely important for everything reasoning. AI-based creation of BIM models. This is building information models. Their comparison with real-life measurements about construction process, collision conflicts you might have, and then dimensional deviations. And we're not only doing it for 3D data and reconstruction that was captured with LiDAR sensors or imaging sensors. We can also do it with radar sensors. So you see a radiogram of what is underground with a ground penetrating radar in this little picture, and then basically you generate then the pipes with this. Or the next step where we're currently working on is taking whole digital twins and generating them directly using AI from videogrammetry. Maybe it's a run through with a GoPro camera, and then building models in there that are later then on used for training purposes. So let's take a look together how these AI-powered digital twins come to life. Let's first talk about simulation, and you're very familiar with robotic simulation. So I would like to show you an example that we're doing in the automotive industry. So basically, simulation here streamlines and enhances the automotive design process, and enables you basically to all the precise insights into fluid dynamics and aerodynamics. I think it's not a secret that we are partnering with Red Bull Racing and the Formula One and many others, automotives here. And these technologies allow manufacturers to test, refine automobile performance, reducing drag and improving the fuel efficiencies. And what works also with automotives also works in terms of wind simulation. It's again computational fluid dynamic simulation that we use then based on digital twins, and digital twins are then used to represent, analyze, and visualize the interaction and influences in urban areas. And of course, that's the point. Digital twins and simulations are used to improve robotic performance. For example, this is our factory where we basically calibrate these sensors. You saw the point cloud, you saw the meshes, and then basically we generate models out of it, and then basically for any robot coming into this factory for us, we deploy or train the robot before deployment there. As you see, for example, with his two Boston Dynamics sport robots carrying the reality capture sensors. So robots capture the reality. The point cloud they create makes the precise foundation. We talk about millimeter precision for our training models. Built upon with the AI segmentation and the photorealistic digital twins. And then we simulate the robotic reality capture and spatial navigation. And this is how we think you can deliver the most accurate form for your robotics performance. And I think this is key to unlock spatial intelligence, enabling humanoids work jointly because you know the environment and you perceive what is moving around with safety and precision, and humanoids then are connected to these platforms. So basically you can play and deploy the insights from these platforms to the humanoids, and the simulation created with large reality models is where spatial intelligence unlocks for real world results. And this will, what we think in the future, also allow humanoids to better understand the world around them and take on increasingly complex tasks. So when we go back to my beginning from data to impact, I wanted to show you how our technologies fully connect digital twins and give humanoids access to insights that will accelerate their performance across all the industries, because we have in a large number of industries, we have actually the experience in building this and building a perfect sandbox before they be deployed into this industries. So with that, I would like to welcome you to the age of autonomy, and I thank you very much for your attention. Thank you so much.